All right, let's dive into a really fascinating challenge in the AI world. How in the world do you get an AI to create data that not only seems real, but actually follows a very specific set of rules you give it? So, here's our game plan for today. First, we're going to unpack why this is such a tough nut to crack. Then, we'll walk through a core 5-step method that forms the foundation for solving it. After that, we'll see how the pros have been fine-tuning their approach, explore some really advanced ideas, and then wrap up by looking at what all this means for the future. So, this is really the big question, isn't it? Can we actually get an AI to spit out, say, a synthetic customer profile that is guaranteed to be a homeowner from California and falls within a very specific income bracket? Well, the answer isn't a simple yes or no. To really get it, let's think with a metaphor. Picture our AI as a digital sculpture. It doesn't start with something to copy. Nope, it starts with a block of pure random noise. This is our digital marble, and its whole job is to carve a realistic piece of data right out of that randomness. Okay, let's dig into the challenge itself. It is a serious balancing act. It's one thing for our sculptor to make a statue that looks like a person, but it's a whole other ballgame to make that statue look like a person and have it hold a specific thing in its left hand while balancing on one foot. And that's the fundamental tension right there. We need the data to be plausible, to feel natural, with all the subtle connections and patterns we see in the real world. At the same time, we need it to be absolutely precise, hitting every single rule we set. If you push too hard on those rules, the data starts to look, well, weird and unnatural. So how do they do it? How do these digital sculptures actually pull this off? Well, they follow a core 5-step process. This is the fundamental technique for guiding that block of random marble into a finished sculpture that follows all the rules. So, first up is data representation. Think of this as choosing the right kind of marble for the job. Then, step 2 is training the model. This is like sending our sculptor to art school so it learns what humans are supposed to look like. Step 3 is defining the constraints. Here's where we hand the sculptor the blueprints for the exact pose we want. Now, step 4, applying guidance, is where the real magic happens. This is where we're actively guiding the chisel as it carves. And finally, step 5 is post-processing, the finishing touches to make sure the final piece is perfect. Now, like any good artist, our digital sculptor has gotten better over time. That core method we just talked about, it's got a few different versions or variants, and each one is basically a smarter, more refined way to guide that chisel. Just looking at the evolution from version 1 to version 2 shows some really key changes. The targets for the rules got way more exact, and the way guidance was applied over time became much more sophisticated. It's like learning exactly how much pressure to apply at the beginning of the process versus near the end. Okay, now this table is where things get really interesting, because you can see how the guidance mechanism itself evolved. The original method was pretty simple. It just nudged the data in the right direction by replacing bits of it. But these later V2 variants, they start using way more advanced techniques, like calculating a gradient. A gradient is basically a mathematical cheat sheet that tells the sculptor the absolute fastest way to shape the marble to get what you want. It's just a much, much smarter way to carve. And the thing controlling all of this is a super important parameter, usually called lambda. Just think of lambda as the guidance dial. It's how we control the strength of our guiding hand on that chisel. If you apply too little pressure, the rules might get ignored. But if you apply way too much, you risk shattering the whole sculpture, completely ruining the natural structure of the data. You cracked the marble. Okay, so we've got the foundational stuff down, but the story doesn't end there. Researchers are now building on this with a whole toolbox of advanced techniques for every single stage of the process, really pushing what's possible. And the innovation can start right at the very beginning in step 1. It starts by rethinking how we even represent the data before the sculpture even touches the marble. For example, you could use simpler encodings to make life easier. Or check this out. You could use another AI to pre-process the data into a smoother, more artist-friendly space. It's kind of like pre-shaping the block of marble to make it way easier to carve the details later. Every idea here is a trade-off between simplicity and power. Next up, we can make the training in step 2 way smarter. This is basically giving our sculptor a much better education before they even start their first sculpture. We could, for instance, tell the model to pay extra attention to rare examples in the data, so it doesn't just ignore them. We could use a more powerful type of AI model, like a transformer, that's just naturally better at seeing how things are connected. But honestly, the most exciting idea here, the real game changer, is something called classifier-free guidance. So here's the deal with classifier-free guidance.
It's like teaching the rules of sculpting so deeply to the artist that they become pure instinct. They just know what to do. This is huge because the rules become part of the sculptor's own intuition, instead of having some supervisor looking over their shoulder and correcting them all the time. It's way more efficient, and the final results often look much more natural.
Of course, the real action is still in step 4, guidance. And researchers have come up with all sorts of creative ways to apply that guiding hand while the data is actually being created. And this is where you can really see the creativity shine. You could have a separate AI referee that's constantly checking the work. Or you could try lazy guidance. Don't bother correcting anything until the very final stages. Another really elegant idea is an annealed schedule. You start with a very light touch while the sculpture is just a rough shape, and then you apply stricter and stricter pressure as the fine details start to come out. And finally, even after all that work is done, there are some powerful tricks for step 5, post-processing. This is like adding the final polish, or, well, even making some quick repairs to the finished statue. Some of these are pretty blunt, but they work. You could just make, say, 3 sculptures and throw away the 2 that don't perfectly follow the rules. Or with post-hoc bit repair, you can literally just force the wrong parts to be correct after the fact. It guarantees you meet the rule, but you definitely risk making the final sculpture look a little, well, glued together. It's a classic trade-off, precision over plausibility. So, after going through all of this, from the basic method to all these cutting-edge ideas, what's the big picture here? What does this all tell us about building these incredible digital sculptors? I think the biggest takeaway is this. It's not about finding one single magic algorithm that solves everything. It's about craftsmanship. It's about building a whole toolbox filled with a bunch of different, creative, and complementary ideas, and then having the skill to know exactly which tool to use for which job. And that leaves us with one last thought to chew on. As these techniques get better and better, and our digital sculptors become true masters, the synthetic data they create is going to become completely indistinguishable from real data, which raises a pretty deep question, doesn't it? How are we going to tell the masterpiece from the forgery?